on example 6. First thing we're going to do is find the vertical asymptotes. So we're going to set the denominator equal to 0. So x squared plus 4x plus 3 equals 0. So that's going to be x plus 3 and x plus 1. So I get x equals -3 and x equals -1. Now something in the other ones that we've done so far today we didn't have to worry about because the top didn't factor much. We need to factor the top and make sure that we don't have something that will cancel out, because that will turn these asymptotes into wholes, okay? So our numerator is x squared minus 3x minus 4, and that factors into x minus 4 and x plus 1. So that means this thing becomes, well, let me write it all out, x minus 4 times x plus 1 over x plus 3 and x plus 1. So the x plus 1's cancel out. So instead of having a vertical asymptote at x equals -1, I have a whole at x equals -1. So basically we're going to pretend this is our function now. We're going to do everything from that because the x plus 1's cancel out. So we still have a vertical asymptote at x equals -3. Okay, so what's the next thing we need to find? Exactly, horizontal asymptote. So we take the highest power of x on top, and this doesn't matter if you go from the original or if you go from after you factored. If we go after we factored, we get an x on top and an x on the bottom. X divided by x is 1. So y equals 1 is our horizontal asymptote. So horizontal asymptote is y equals +1. So go to your graph paper. So we've got x equals -3 and y equals +1. We'll deal with the fact that we've got a hole after we sketch our graph in. Okay, so then, let's look at our equation here. We need to find our x and y intercepts. So if it helps, make an xy chart, plug 0 in for x and 0 in for y. That's basically what we're doing. So if I plug 0 in for x into, remember our new function is x minus 4 over x, and it won't matter. You could plug it in at the beginning. If you plug it in here, you get -4 over +3. So -4/3. So you can go ahead and plot the point, 0, -4/3. Then if y is equal to 0, that's when our numerator is equal to 0, and our numerator is x minus 4. So when x equals, when x equals 4, I would get 0 for my y value. So I have the ordered pair 4, 0. 1, 2, 3, 4, 0. Okay. Now we need to see if it crosses this horizontal axis anywhere. So we need to take our function, x minus 4 over x plus 3, and set it equal to 1. I could use the original, but this is simpler, and they're equivalent to each other. So I might as well use the simpler one. So if I multiply both sides by x plus 3, I get x minus 4 equals x plus 3. The x's cancel. I get -4 equals 3, so that's no solution. So that means there's no cross points. So if I know that it does not ever cross this dotted line, then I know that it does this. And I know that it has to approach this asymptote, so I know that it does this. Now, we had a hole at x equals -1. So I need to go to my graph and go to where x equals -1 is and just draw a hole in there to show that there's a gap. There's a place where the function is not smooth. There's a hole in the road. Now I need one more piece of information. What else do I need to do? Plug in one more point, and the point needs to be smaller than -3 because I need to know over here if it's above or below the asymptote. So if I plug in -4, so So I've got x minus 4 over x plus 3, so that'll give me negative 4 minus 4 over negative 4 plus 3. That's negative 8 over negative 1, so that's positive 8. So when I plug in negative 4, I get a positive 8. So 1, 2, 3, 4, 5, 6, 7, 8. So this graph is going to approach that, and it's going to come down. And again, you don't know exactly how steep this is and how quickly, you know, does it come down straight and then curve, or almost straight, or is it really, really a small slope? You'd have to plug in a few more x's to get that information, and all I care about is that you understand that it doesn't cross this line and then it gets closer and closer to both of those asymptotes.